Building America program. Today's panelists will focus on specific Building America projects that are looking to gather and analyze large bodies of data on new and existing homes, and will feature opportunities for industry to collaborate with researchers to gather and analyze valuable data. I am Stacy Roska with the National Renewable Energy Laboratory. I have the privilege of working as a research coordinator for the Building America Industry Research Team. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or over your telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, you will eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right side will display the telephone number and audio PIN you should use to dial in. Panelists, we ask that you please mute your audio device while you are not presenting. If you have technical difficulties with the webinar, you may contact GoToWebinar's help desk at 888-259-3826 for assistance. If you would like to ask questions, we ask that you use the questions pane where you may type in your questions. If you're having difficulties viewing materials through the webinar portal, you will find PDF copies of the presentation at the website listed here, and you may follow along as your speakers present. Also, a recording of the webinar will be available on the DOE YouTube channel within a few weeks. We have an exciting agenda prepared for you today that is focused on Building America projects that are collecting large data sets in order to help the industry answer some of the important research questions. Speakers will get into the details of these efforts later. Before our speakers begin their presentations, I will provide a short introduction of the Building America program. Following the presentation, we will have questions and answer session and closing remarks. The U.S. Department of Energy's Building America program has been a source of innovations in residential building energy performance, durability, quality, and affordability, and comfort for nearly 20 years. This world-class research program partners with the industry to bring cutting-edge innovations and resources to the market. Building America uses applied research to deliver building science solutions. These innovative solutions are tested in real-world homes to develop proven case studies of success that the market can point to. Oops, sorry, I skipped a page. Let me start over with who we are. Building America is supported by 10 industry research teams and 4 national labs. Each of these teams and partners with dozens of industry professionals, including builders, remodelers, manufacturers, and utilities. The best and the brightest in the residential buildings industry can be found here. And now we'll talk about what we do. Building America uses applied research to deliver building science solutions. These innovative solutions are tested in real-world homes to develop proven case studies of success that the market can point to. Building America provides the tools the building industry needs to ensure innovations are applied correctly. And the final step, infrastructure development, is the conduit in getting innovations to the marketplace. The 4 steps make up the framework for the Building America program. Building America started with a focus on researching how components of the home work together. As I stated previously, energy performance, durability, quality, and affordability have always been the top of our priority list. As the market changes and evolves, so has the direction of our research. Now solutions for existing home improvements are needed as well as new construction. In addition to technical challenges we have been addressing for decades, there is now a need to understand market transformation items, such as the valuation of energy efficiency to our portfolio. In the 19 years that Building America has been around, we have spearheaded combining ultra-high efficiency with high performance in both new and existing homes. And we actually consistently are achieving this challenging task. In 1995, a typical home uses over 3 times as much energy per square foot compared to today, and indoor air quality, comfort, and durability problems were common. Today, a home built to the DOE Challenge Home specification uses less than half that energy, costs less to own, and is more comfortable, healthy, and durable. In 2030, Building America will demonstrate that new and existing homes can produce more energy than they use. Do you want to know more about these proven innovations? The Building America Solutions Center is your one-stop source to expert information on hundreds of high-performance construction topics, including air sealing and insulation, HVAC components, windows, indoor air quality, and much more. You can find it by the URL on your screen or Googling Building America Solutions Center. And now on to the talk that you came here for. The Building America webinar series takes the place of the public meeting series that Building America put on previously. By having our sessions presented in this way, we hope to reach more people who wouldn't otherwise be able to attend the meeting. The topic today is opportunities in large data collection and analysis. The goal with this webinar is to give a quick overview of some interesting data collection efforts across the country. If you would like more detailed information about any of these efforts, or if you're interested in collaborating, please feel free to contact any of our presenters. Our first speaker today is Omari Fachi. Omari is a building systems engineer with Stephen Winters & Associates. I look forward to hearing how Omari transfers his data mining experience related to predicting credit card fraud to developing multifamily envelope leakage models. This helps support my belief that air leakage is like a thief in the night when it comes to energy bills. Next up is Noel Marquette. Noel is an engineer at the National Renewable Energy Laboratory. Noel is NREL's go-to guy to make data behave. There is no better place to apply Noel's skills than in establishing some discipline through the Building America Field Data Repository. Finally, we will hear from Chuck Booten, Paul Norton, and Sharon Mexner. This is NREL's three-headed monster attacking indoor temperature and humidity data collection and analysis. Really, what is the temperature in here? With that, I would like to welcome Omari to start the presentation.
Good afternoon, everyone. Hopefully it's afternoon everywhere in America. So I'm going to start off this presentation talking about multifamily envelope leakage model. So Stephen Winters Associates, also known as SWA, embarked on a journey to try and create a model to predict leakage to the outside with the help of the DOE, Department of Energy, Building America program. In this presentation, I'm going to introduce multifamily air leakage testing, talk about the problem of why we need to predict air leakage to the outside, and then state the steps taken for a solution, talk about model results, how the model can be applied, and the benefits of the model. So multifamily air leakage really has been a way to try and recently energy programs have been using to comply to their standards. It's a way to also measure and verify how the building performance, energy performance is. It's also very useful in determining the indoor air quality of multifamily units. There are several ways in which air leakage in multifamily buildings can be tested. I'm going to talk about two main ones. One is the unguarded blower door test. An unguarded blower door test, basically, as you can see in the figure, is a way of pressurizing, is a way of testing the air leakage in a unit by depressurizing. In this case, in this presentation, I'm only going to be talking about depressurization. It's a way of depressurizing a unit and then measuring how much air is leaking through all the panels of that unit. So as you can see in this diagram I have over here, the red line shows the air leakage path through the unit of interest, which is the light blue. The other kind of air leakage testing that I'm going to be talking about is the guarded blower door test. And this basically involves depressurizing not only the unit of interest, which is in the middle in this case, but any adjacent units. So if you look at this three-dimensionally, it would also be all the units on top and all the units at the bottom of this unit of interest. And this test basically helps us to measure leakage to the outside. So what's the big deal? Why are we interested in these two different kinds of tests when it comes to air leakage in multifamily buildings? A reason is because when you want to make an energy benefit measurement of a retrofit, for example, doing a guarded test on a building pre and post retrofit gives you a better and more accurate energy benefit prediction. However, if you do an unguarded test, pre and post retrofit, you sometimes run into over predicting the energy benefits of air sealing. But the issue here is that it's cheaper to do a solo test, which is also known as unguarded. It's quick, less expensive, you use less personnel, and you're dealing with less tenants because you take your blower door, you go into one room, and then you run your air leakage test, and you're done. For a guarded test, usually it's very labor intensive. You have time, it takes a lot more time, it's a lot more expensive, and you have to coordinate with a lot more tenants just to get this value. Now, the guarded value is what we want in order to get a better prediction of basically to get a better prediction of air sealing. So then how do we get this value in a much less costly way, which is basically our goal. So to embark on this solution, we took, these are the steps we took. We went around to collect data from different kinds of, from different locations, and all these people gave us blower door tests that were done through depressurization. We sift through the data to find out what variables could help us predict air leakage. And also we analyzed the data and then try to create a model. Now the data comprised of each row or each line in the data was comprised of a blower door, an unguarded blower door value, and a guarded blower door value. Each row also had unit specifications of each unit that we're interested in. And basically we went ahead to use these specifications to create variables that were going to be used to predict air leakage to the outside. To give you a kind of a profile of how our data looked like, we worked with 17 buildings, 236 units. The climate zones that these units came from were from 3 to 6. Now these numbers do not necessarily represent the exact climate zone. So for example, for climate zone 5, we basically took all buildings that were both in climate zone 5 and 4 marine because they sort of form into the same code, IECC code construction type level. Mainly also we dealt with low-rise multifamily apartments and also townhouses. These are the variables that we considered: common wall area, window area, door area. There were a whole host of these variables, and we were sort of daunting. So we figured, how do we go through all this data and pick out the most significant ones, like I mentioned earlier? We passed the data through a stepwise regression. Now this stepwise regression basically goes through all the variables and tries to find out which variables better predict or are more significant to predicting air leakage to the outside. Through that, we discovered that climate zone, duct location, whether it's the ducts or whether there were no ducts, whether it was in conditioned space or unconditioned space, door area, shared surface area, and a shared surface area is when you have two units, basically the area of two units touching each other. And the envelope perimeter is basically the area of the length of all the corners where two panels of an envelope meet, and then the age of the building, of the unit. By running the model, we've came up with this equation, 0.86 being constant, alpha 1 and alpha 2 being alpha 1 representing the climate zone, alpha 2 representing the duct location, and then x3 to x6, the various variables. The constant in this equation basically is saying that represents the average ratio of guarded value over unguarded. So basically, if I were to divide the average guarded value of all the data that we got by the unguarded value, we get a ratio of 0.86. So meaning that the guarded value is 86% less than the guarded. The unguarded value, the guarded value is 86% less than the unguarded value on an average. To apply this model, I set up a quick example here in this table. So let's say that we have a unit that came from climate zone 4. The dark location was found in conditioned space. Door area was 18, surface area was 1,052 square foot, and envelope parameter was 396, and age was 43 years. We multiply these values by the constants, which you can see is in the coefficients, which you can see is in the second column, and then you get your results. You sum all of that up, and that gives you a ratio. Now this ratio can now be multiplied by the solo test. So for example, if I go out into the field and I want to find the guarded value, I can do a simple, quick, and cheap unguarded test to get, in this case, it's 842, as you can see. And you come in, you put your the specifications into this equation, and you come up with a ratio. When you multiply the ratio by the unguarded value, you can now get your guarded blower door value. So basically, we went ahead to try and apply this model to data that did not go into training the model. So we took 60%, we took 40% of the data out of the model, and then out of the data sample, and then trained the model with 60%. Now that 40%, which didn't go into the model, we ran the test of the model on it and came up with this graph. And this graph basically shows predicted leakage, predicted guarded values against measured guarded values. And from the graph, the blue dots basically being close to the red perfect basic line shows that the model was sort of doing well. The benefits of this model, which I've been talking about mainly, is that it saves you money and time. You get to use less personnel, and overall it's very convenient. Now, like any model, this model certainly could use a lot more work. So we basically looking to validate this model a lot more, also looking to get more data to improve the accuracy of this model. The benefits of this model could also be, in a sense, could be used in energy modeling softwares like REM, Treat, Equip, so much so that when you go into the field and you want to, and you do an unguarded test, you can just pick this value, put it into these software, and it will automatically generate an unguarded value, which is much more accurate in predicting the benefits of air sealing. Yeah, and that's it.
Thanks, Amari. Now we will move on to Noel's presentation.
All right, hi everybody. This is Noel Raquette, and with the National Renewable Energy Laboratory. And I'm here to talk to you today about the Building America Field Data Repository and kind of the data we're collecting and what we're doing with it. So, I guess the first question that we all ask is, what is the Building America Field Data Repository, or BAFTR, besides being more proof that engineers shouldn't be allowed to name things? I guess the best way to talk about it is kind of to tell the story about how we got to here, from where the idea came from and how we got to here. So several years ago, the Department of Energy began focusing on existing homes and retrofits, and they were looking for evidence that retrofits actually delivered the energy savings that were being promised to people. And we began looking for it, and there wasn't a whole lot of data easily available. I mean, there are several programs out there, people that had collected data about retrofits they'd done through their utility programs or weatherization programs, but it was not all in one place, and there was spread out in a lot of different formats. And so, the real question is, we want to be able to answer is, are we able to deliver those kind of savings? So, the idea behind the Building America Field Data Repository is to develop this repository of residential building characteristics data and couple that with energy use data, so like their utility bill data or even sub-meter data. And that can be used to answer questions like, how well are we predicting energy use based on building characteristics, and, where it's not predicting right, what's causing the issues. And also, how detailed of an audit do we need to do to accurately predict energy use for buildings. So, to build a data set like this, you have to look both backwards at the data you are able to collect already and forwards to the data you want to be able to collect. And looking backwards, we've been kind of beating the bushes and collected a number of historical data sets, maybe not quite as old as that picture shows, but from weatherization programs and utility programs for retrofits. And they'd come to us in many different levels of detail and different formats, and we can I'll talk more about how we dealt with that later. Moving forward, we have, working with Building America, there are a number of homes that Building America touches and is involved in, and we wanted to be able to collect data on kind of the impact of Building America and what we're doing in those homes. And so by looking backwards, we could see what data had been collected and how useful that was, and to determine what would be useful to collect for data in the future. And to make this a successful reporting platform for Building America. Also, through Building America, there's a lot of field monitoring done where they're sub-monitoring different equipment that's being tested in homes or different lab homes to see, precisely how things measure up. And with that, that's kind of a special case of data that we needed to be able to handle in this database as well. So, kind of all three of these cases, we need to be able to store this data and to use it in some kind of consistent, useful way. So, when you look at it, I kind of want to talk about how we got from wading through the historical audit and utility data and talk about the capabilities we've developed to make it work. So you get this data in all kinds of different formats, and really it contains two kinds of information. There's building characteristics and the energy use data, which is utility bills. And the challenges that come from that are, one, getting enough data so it's actually statistically meaningful. When you're just kind of asking, you get whatever's there, and so it tends to be very regional, which is still an issue. But and the other issue is making the format so it's all standard. I mean, there's just so many different ways you can describe the same thing and transmit it that you can gather the data, but it's not useful unless it's in a format you can use across different data sets that you've collected. So what we've been doing is over the past couple of years, we've collected a number of data sets. These are kind of our list of historical data. And some of it has more detailed data than others. I mean, we have some that has both, characteristics, billing data, and pre and post upgrades, so we can see how the upgrades affected the billing, or, the utility use. And some that has quite a bit less data than that. And each of those has maybe their own utility or use case, but, so there's kind of a spectrum of resolution to the data that we've been collecting. And like I was mentioning earlier, you get kind of whatever is out there when you're just asking people to send you their data. And so we've got, all kinds of spreadsheets, even PDFs of utility bills, which has been, that one's real fun. That one's hard to work with. So the question then comes up, when it comes to you in all this ways, it's not inherently useful because you have to be able to dig into that data and to find it in some systematic way. So the question became, how do we standardize the format? And when we first started looking into this, we shopped around to see if there was a generic format out there, and there wasn't a lot available. And even at one point, we considered kind of making our own superset of the different formats that we had found. And about this time we got involved with a working group that developed, through BPI, that developed Home Performance XML. And became really involved with that to develop an industry standard language for communicating home energy data, both the building characteristics, the measures done to the buildings, and the utility data along with that. It was a good choice for us because, you know, at the time, and especially now, there's a lot of industry momentum behind that format, which has been really encouraging to have a lot of the people that are at the table there. And the benefit for us looking forward is that, you know, as more people start using HPXML in their software, then as we come around and ask nicely for data, then it is already in a format we can consume pretty easily. So, and another advantage for us is that we kind of got in at the ground floor, so we could be involved in the development of the standards so that it would, you know, meet the needs that we had. So, you know, over the past couple of years now, we've been collecting the data, and this graph here you'll see is the orange line is the data we've got, you know, number of homes we have from different sources, and the blue line is the data we have translated into HPXML. So you can see we're kind of getting just about to 10,000 homes in the HPXML format right now, and they're kind of spread out in some different places. So when you take another look at that and put all those on a map, all the little blue dots are places, are locations where we have data. As you can see, it's still kind of geographically clumped in certain areas. I mean, we have good representation in the Pacific Northwest, Iowa, some places in the Midwest, and a few other places. But, you know, California is pretty empty for the data we have, and most of the West and Southeast, and much of the Eastern Seaboard actually is still pretty sparse. Doesn't mean that the data we have is not useful, but, you know, it's kind of makes it more regionally specific. So, you know, one of the things we're still doing is trying to find more data sets that fill more geographic regions to make it more meaningful. So, you know, when the purpose of all this data is to do research with it. So, you know, you have your building characteristics, your energy use, and then through data visualization and statistical analysis, we can tease out trends in the software predictions, inaccuracies, and identify their causes. And so to do that, we built this software, this translation and energy simulation layer that allows us to run the same homes through different software and compare them to their weather normalized energy use. And we built all of that translation and everything on HPXML. So, and it's allowed us to do some pretty interesting analysis. One that's been out there that I think many people may have seen is the analysis of the home energy score software compared to some other energy rating softwares that are commonly in use, and to see, you know, kind of where it falls short and where it, you know, it does well. So moving forward, as we're looking at collecting data coming in from Building America, we've built the HPXML export capability into VOPT so that, you know, it's a push of a button and all that building characteristics data that people are modeling in VOPT, which I failed to mention is NREL's residential energy modeling and optimization tool. And it's a tool that a lot of the Building America teams use, that they can easily push that data into the database. And we can see, you know, the effects that the Building America program is having using this data. And then, as I mentioned before, as more people start using HPXML, we can be able to kind of fill out that map a little more and have more data that we can use to make more sweeping predictions and analysis about energy use across the country. So, that's kind of an overview of the Building America Field Data Repository. And if any of you out there are listening have data you'd like to contribute, we'd love to talk. There's my email address. And if you're interested in HPXML, there's the website to go see that. And look forward to answering your questions that you have a little bit later.
Thanks, Noel. I want to remind the audience that if they have questions, to go ahead and submit those in the questions pane. And now we will move on to Chuck, Paul, and Sharon.
All right, this is Chuck Booten. So here with Paul Norton and Sharon. And we're going to be talking about indoor temperature and humidity data collection. So this, in some ways, is kind of similar to what Noel was talking about, where we're looking at trying to get lots of data and seeing how we can analyze and how we can deal with that. So why do we care about temperature and humidity? So generally speaking, there's a tendency for models, building simulation models, to over-predict energy use. And one of the things that might contribute to that is indoor temperature settings. So whenever you're doing some modeling, you have to assume something about what the temperature is like inside. This might be a good way to go about addressing this general over-prediction. So here on the right, this graph, the vertical axis are different characteristics or inputs into building energy models. And the horizontal axis is, you can think of it as kind of the relative importance of these inputs. And you can see that the top two inputs, by far, are the heating and cooling set points. So these are the strongest drivers, the biggest levers that you have in terms of energy use of the home. And so if you really want to understand this, you want to understand the prediction, you need to deal with this. Now, notice that those are both temperature set points, and we're looking at RH as well. The RH doesn't really have much of an effect on the energy use, but it is an important parameter. I mean, it does have a lot of effect in terms of comfort of people and the durability and safety of the house. So our thinking was, if we're really looking for the temperature, it doesn't take a whole lot more to get the RH if you're already in the house. So it's kind of a free rider, but it actually has some real benefits. It's not just extra data that you're collecting. So, and I guess actually, I'd say a little bit here. I mean, the reason that the temperature, humidity, temperature set points are such a big deal is that space conditioning is by far the largest energy use in most houses. So, so this is a great place to start. Now, if you're doing simulations, we have what's called the Building America House Simulation Protocols, and this is kind of a standard set of assumptions for things that you have to model in a house. So things like schedules or temperature set points, things like this. So in there, we have the temperature set point for cooling of 76 and a set point for heating of 71 Fahrenheit. So these are just two simple numbers. You have to assume something, of course, and the question is are these the right numbers? But this at least gives you an idea on the starting point, kind of the baseline that we're starting from. Then you look at some of the research. So there are some initial studies looking at the variation of temperature and humidity and moisture within buildings. And these really sort of raised some eyebrows and kind of highlighted the fact that there's a lot of variation. This one number is not the best. It's not as accurate as you would like it to be. This is reality, and there's a lot of spread. So not only do you have to deal with the mean, is it right on average, but if there's enough of a spread, you might need to collect a little bit more information so that you can really understand how houses are actually used and how they operate. But this is really just the tip of the iceberg, and then that kind of motivated the research that we're doing right now. So the research that we're doing, what data do we need to understand this? So we need hourly temperature and humidity measurements in the living room and all bedrooms within a house. You also need to have an idea on the outdoor conditions and the runtime of space conditioning equipment, which it turns out that that can be pretty important. If you're not running your HVAC system, then if there's variation in the temperature in the house, that's interesting, but it doesn't really affect your energy use as much because you're not putting any energy into it. Ideally, we'd like 1 year of data, although if push came to shove, we can deal with less, but I think ideally that's what we'd really look for. Now, one of the things, I mean, I'll make a pitch here the same as Noel, is that not only are we doing this study, but if there are other people out there who are doing similar studies, or if you think you might be doing similar studies, we might be able to help. And we want to talk about it. And we might be able to provide some support so that we can help you with your project as well as helping us with ours. So one of the things that we developed to kind of streamline this process is a temperature and humidity measurement protocol. So this is for anyone who's collecting temperature and RH data in houses. And it really doesn't matter exactly what your use is. This is a good guideline that you can use. And what it does is it standardizes and gives you a guide and some best practices for how you should install data, what kind of data you need to take, what kind of information you want to gather about the house. And then the standardization not only makes it easier for the people who are out in the field doing this, but it also makes it a lot easier for the analysis. And ultimately, that's what we want this for, is we want to be able to slice up and dice up this data so that we can improve our simulation models. Now, if you're interested, you can see this barcode here, so that'll give you a link to the protocol if you're interested in taking a look. Current project scope, so we developed and implemented this protocol, and we are looking for data on about 350 homes or more. We're collecting data for the next couple of years, and then after we have a chance to analyze all of this, then we'll update the simulation protocols and of course make all the analyses public so that other people can benefit from it as well. To give you an idea on where we stand right now, so this is a table of some of the data that we currently have. We have about 120 homes worth of data right now, and in 2014 we're looking to add around 70 or at least 70 more. And this just gives you kind of a flavor for where things are. There's some single-family homes, some apartments, and different climate zones. Another way to look at this data, and this is perhaps more useful, this map kind of shows where we have information, but more importantly, I think it shows where we do not have information. So if you're looking at this map and you're saying, I'm planning to gather data in some place where we don't have any, let's talk. Either if you already have it, that's great. If you're planning it or it's in process, we might be able to help you with that. We might be able to work together so that you can get more information, and then so can we. So I guess with that, I will turn it over to Paul. We'll start talking about the data a little bit.
Good afternoon. Paul Norton, and we thought we'd give you a taste of some of the preliminary results that we're seeing. We're by no means finished with the analysis, and as Chuck has mentioned, we are nowhere near as many homes as we'd like to get before we can draw any conclusions. But we did want to give you a taste of what we're seeing initially. This chart shows frequency distributions for temperatures in 4 sets of homes in 4 different areas around the country. So along the bottom x-axis, you see the temperature in degrees Fahrenheit, and the y-axis is the percent occurrence of that temperature. So you can see at a glance that these different groupings of homes have slightly different indoor temperature. These are living room temperatures. And each are different from one another. They're different both in the spread of the frequency and in the mean. And the red vertical line there is the current home simulation protocol set point for heating. So we're seeing some groupings below that set point, a little bit above. We'll need to collect additional data before we can make a determination on whether that simulation set point should be corrected or adjusted. We have just one preliminary analysis for cooling now in 20 Florida homes. And again, the vertical line is the home simulation protocol set point for cooling. And we can't really make any conclusions, obviously, with this little data, but there's a taste of what we're starting to see. Now, this graph shows the same 4 groupings of homes that was shown in the heating frequency distribution, but now we're looking at not the living room temperature, but actually how much does the temperature vary between the average of the home and the bedrooms in the home. So these bars give a sense of how much we see room-to-room temperature variations within the homes. And you can see in each of these data sets that the in some homes, we see bedrooms that are warmer than the average house temperature and some that are cooler, and sometimes by a substantial amount. And each set of homes has a different amount of room-to-room temperature variation. So the room-to-room temperature variation we're interested in to see most models these days are single zone. They assume a uniform temperature, and we want to test if that assumption is valid enough to give us accurate results. This is a little busier graph. This is some initial results on humidity from a project of 8 homes in New Orleans. These are recent results. Each set of bars along the bottom is a different home. So PHA 1 through 8 are each individual homes. You can see they're divided into 2 sets, 4 homes with dedicated dehumidification and 4 homes without. And the y-axis is the total number of hours between above 60% RH. And the individual bars are monthly results, but what I want to focus on right now are the red horizontal bars, which are the annual average hours above 60% RH. And you can see that it's highly variable from home to home. And one of the kind of interesting, somewhat perplexing results in this study were that 2 of the homes with dehumidifiers that are circled on the left actually had higher average hours above 60% RH than 2 without dehumidification. Now, this particular project was taking detailed data on every one of these homes, so we have some additional information on each home. And what this graph shows is shows the hours above 60 RH, and in each box we're showing whether that quantity on the left is about average of the total community of homes or above or below average, high or low compared to the average. So the top shows the number of people in each home, and then along this list of measurements, you see things that can contribute to the indoor humidity, such as the use of your bath fans, the dehumidifier use, heat pump use, how much hot water is used, cooking, electricity, and clothes dryer. These are all things that can contribute and can be explanatory variables for the humidity level in the home. And what this little data visualization was put together for was simply a visualization of pattern matching to see if the patterns we were seeing could be easily explained by some of the other variables measured. We have plans to do a regression analysis on this. That'll give us more quantitative data. But qualitatively, you can see that, you know, homes with high occupancy tend to have higher humidity ratios, which is absolute humidity. However, the hours above 60% may or may not be high. And it turns out that one of the homes with high occupancy had low relative humidity, probably because of high indoor temperature set points. So all of these interact with one another, and it's going to take additional data and analysis to start to tease out a better understanding of the variability of humidity in homes and how we deal with that in our modeling.
So to kind of summarize a little bit of what Paul was talking about, so there's a lot of variability in temperature and in humidity, and so we need more data to really be able to improve our modeling assumptions. So I mean, there's within houses, within areas, time of day. I mean, there's all sorts of things that can vary on. You need a lot of data to answer those kind of questions. One of the things that is missing in a lot of our initial data is space conditioning equipment runtime. It's not clear how necessary this is, but we need more data to kind of figure that out. And then, you know, I would say that the early data, again, it kind of indicates that maybe this set point that in the house simulation protocols is too high. That's certainly a preliminary analysis that could change, but again, we want more data. We want to get this right. So continue with this theme. This is the NREL theme here. We want more data, but we want to collaborate with you. I mean, if you have projects, we might be able to help you with that. This isn't just us asking for freebies, although if you have the data, we would certainly love to have it. But if you're planning to do more work, we might be able to help you get more done than you otherwise would have. And and then also that one of the things we'd like to do is to expand the scope of the existing data. So this is something that both Noel and Paul and Sharon and I we have. You see we have data in certain locations, but there's a lot of locations where we don't. So older homes, different climates, more single-family homes. For our particular study, it's easy to get more data on a multifamily home, oftentimes than it is to get the large number of single-family homes. So these are some of the things that we'd want to consider. But again, just give us a call. So further analysis, things we could look at is time of day variations. It's important not only is there variation within a house, so within rooms in a house, but then there's also variation between houses. So these are distinctions are maybe a little bit subtle, but you need a lot more data to kind of tease that out. And then, as Paul mentioned, doing some regressions to look at what are the important variables. This is kind of a sample of some of them, but potentially not all of the important variables to look at. But the more variables you have, the more data you need to get it right. So if you are interested and you want to talk about this a little bit more, feel free to send me an email or give me a call. And yeah, I'd love to hear from you.
Thanks to the panelists for the outstanding presentations. We have some great questions from the audience. What I will say first is that there's a lot of people that have volunteered data, which is fabulous, and we will be connecting your information with the respective presenters to coordinate that. Let's go first to a question for Omari. It is the data you collected from the 17 multifamily buildings sufficient for predicting energy savings potential at a level of certainty needed? And this is a two-part question. Is there ongoing work to collect more data, other climate zones, and other types of multifamily homes?
So, good question, by the way. Just with Chuck's group, we are also in need for more data. The values, the broader results that we got from people, we had to assume that they were accurate, because in order to go ahead with your model, you have to assume that they did an accurate job. But then the more data you get, the more you're able to cancel out the various kind of errors from each measurement. So we are really looking to get more data. The hard thing about getting data of this kind is that you need a unit that has both unguarded test and a guarded test done on it, because we need both values to create that ratio, which is what our model kind of tries to predict. So it's an ongoing process that we're calling out to people to try and see where they can help us bring in more data to help strengthen this model.
So the next question was directed at Noel's presentation, but I think it pretty much goes for everyone. If there is a public distribution plan for the data that you guys are collecting, and is there a process for autonomizing the data, and what is the mechanism for this distribution?
Yes. So the main plan for distributing the data in the Building America Field Data Repository is I don't know if you've heard that there's a similar effort going on within the Department of Energy called the Buildings Performance Database. And we are scheduled to deliver our data to them, and they specifically manage the public distribution of the data. And so they will have the data points that we have, plus what they have collected independently that we don't have, specifically because of non-disclosure agreements. And they do a really thorough job of anonymizing the data.
I think for the temperature and humidity data, it would be the same. I mean, the mechanism is really to kind of put these into the field data repository and take kind of the same approach. So.
Yeah, on the same end too, I think it would be nice to have that. We haven't actually thought about how to kind of put the data out there, but it's just basic units and their specifications with unguarded and guarded tests. So we'll look into it and see how we can present it to the public.
Okay. The next question is for Chuck and Company. Regarding the Building America House Simulation Protocol, is that being updated for the 2009 RECs, and how does the result compare to the current protocol?
So the protocol, typically, this is Sharon from NREL High, sorry, I haven't talked yet. So there was a time when the protocol was being updated annually or semi-annually. At this point in time, we actually are planning on essentially waiting for the indoor temperature protocol information to come out to update the house simulation protocol again. And that's just because with the cycles of codes and everything else, we've actually found that we're still sort of relevant with the current HSP as is for now, maybe besides this issue. So, so I guess it won't be updated maybe for another couple of years at this point.
Chuck, what is the vintage of the homes you're looking for so far, and what vintages do you need?
This is Paul. I'll field that. About 80% of the homes we have now we would consider existing homes, and about 20% were built just before the temperature measurements were made. So, and then the existing homes vary from 1902 to 2007, but there's definitely a heavier emphasis on more recent vintages. So I think we'd like to continue that, to see that kind of diversity in the new homes that the new projects that we add to the TNRH study. I think we're a little heavily weighted on new homes, so we probably would not be looking for as many new homes, and we are more weighted on the newer of the existing homes, so we'd like to see older vintages. Hope that answers the question.
Okay, the next question, how will you, and this is again for Chuck and Company, how will you account for human behavior? Homes used for models will generate results based on the current inhabitant's personal interior temperature preferences. Once the home is assumed by another inhabitant, the data will change based on the person's personal preferences.
That's absolutely true, and you know, we see, if in identical homes, we see energy use that varies by coefficient of variance of about 40%, which is the standard deviation over the mean. And most of that is due to occupant choice and behavior. And a big part of that is occupant choice in their temperature set points. So this is the reason why we need a large sample of homes, because of the variation, even with identical homes, in the different set points and the variation in what people feel comfortable. And the current house simulation protocol specifies a single set point, and we want to get that single set point as accurately as possible to represent the mean of all the variability that's out there. At the same time, we recognize that that single set point model can probably be improved upon. So, you know, the primary result of the TNRH study will be to improve on that single set point, and a secondary objective is to look at other ways to model indoor temperature other than a single set point that can more accurately predict energy use and take some of that variability into account.
I think we have time for one more question. This was also for the temperature and humidity data collection. Should we be discussing crowdsourced data collection models that collect from autonomized households that install an inexpensive temp humidity sensor and then upload a smart meter data? This data would be less than complete, but it may be collectible at large volumes.
Yeah, I mean, I think certainly we've thought about that at various levels, and yes, it's absolutely important. And like you said, it's not the most complete data, but you have lots and lots of it. So one of the things that towards the end, I mean, I kind of pointed out that there are inter-house variations, so variations from house to house of the mean, and then there are intra-house variations, so within that, how much does it vary? That data would certainly go a long way to answering one of those questions, and that's, that's really important. And so, yeah, absolutely, it's part of the discussion. We are, I can't say that we're in a position to do anything like that right now, but we have been thinking about it. We are looking at ways to try and collect some of that data. And if anybody has any particular ideas or anything like that, I'm happy to discuss more. Yeah.
NREL has also had some discussions with the folks at Nest thermostats, which are basically internet-connected thermostats that can record indoor temperatures. So that would be similar to the suggestion of the participant in terms of collecting large amounts of data. To date, we have not been able to get our hands on that kind of data, but we'd certainly be interested.
Great. So we have, thank you again. And now before we go on to our quick survey, I'd like to give the panelists an opportunity to provide some additional closing remarks before we close up.
Send us more data. Let's work together. And we can try and help you get more data too.
I think, and one thing to keep in mind, those participants who are listening now and are engaged in projects nationwide that gives them access to homes and maybe doing some kind of research objectives of their own, there's the possibility of partnering with us to actually improve your data set by getting temperature and relative humidity throughout the house, and in return providing us access to the homes that you are already gaining access to. So think of it that way. If it looks like there's an opportunity, give us a call. We'll talk about it, see if we can create a win-win situation.
So from my end, it's basically we're really trying to save the cost and time of doing a guided blood or test. And so with the help of more data, I think that would really help everyone to go in there and do better and more accurate energy assessments of retrofits. So, and air sealing.
So I would say thanks for this opportunity to talk to you all. And yeah, if you have any ideas or suggestions for our approach on the Building America Field Data Repository, I'd love to hear from you. My contact information is on the slide. And thanks again.
And I would say to the panelists, again, we've had a number of people offer up data sets that they have available, and I appreciate that. So keep it coming. Thanks again to the panelists. Now we'd like to ask our audience to take a minute to answer a quick survey on the webinar you viewed today. We have 3 short questions for you to answer. Your feedback is very important to us as it allows us to know what we're doing well and what we can improve. And Heather's got those questions up now. So if you could please answer the first question. And the second should be coming. There it is. Whoops, maybe. Okay, and the third question. Stay tuned for our next webinar on May 21st at 3 p.m. Eastern. This will be the first of a 2-part series on enclosure retrofit results. This should be a stimulating conversation with the Northern Star and Abacus Building America teams presenting on solutions for the existing homes. On behalf of the Building America program, I'd like to thank all of our expert panelists and our attendees who are participating in today's webinar. We've had a terrific attendance, and we very much appreciate your time. I invite our attendees to check the Building America website over the next few weeks if you'd like to view the slides as well as previously held webinars. Additionally, you will find information on upcoming webinars and other training events. We also invite you to inform your colleagues and those in your network about the Building America resources and services. Have a great rest of your day, and we hope to see you again on a future Building America event.